Of introduction. I would like to thank all the assistants for being there. It's quite an important step for us, this webinar, because we are 6 months away from the end of the project, and so it's quite important that we start to share results and try to create momentum around our proposals. A bit of history to start. So as Evaldas mentioned, I was involved early on in this effort, and this effort started actually in December 1998 at a DARPA workshop. So DARPA is the Army, the military research agency in the US, and they were funding at the time a lot of intrusion detection projects, and they had a problem, which was how could we compare the various performances of the sensors that they were developing. So they decided that in order to have a good comparison basis, all the systems should share the same output format. And so we had this meeting in Washington, D.C. at NIST, where the idea was, amongst researchers, let's discuss what an output format could be. We had several discussions, but in the end, what was proposed by the people who became then working group chairs, Stuart Staniford and Mike Erlinger, was the decision to form a working group at the IETF, which became the IDWG working group. And the working group was charted in 1999. It took a while, and we established the objective of the working group around 4 documents. One was the vocabulary, the description of what intrusion detection was about, a data model, what kind of data do we want to transport, a format to implement the data model, and a transport protocol, which actually was the justification of going to the IETF. And an initial description of the data model was done using Lisp, but it was felt a bit too complicated. And then we quickly moved to XML. There were some discussions as to what could be done, but it took a significant amount of time to produce the format. There were about 10 drafts of the format proposed, with different adjustment points related to how should we represent various kinds of data. And this was done using a UML-like of class design. As I was developing the format, other people proposed representation of the format as SNMP or XML. And in the end, there was a significant debate in the working group as to whether we should choose SNMP or XML. And there was a vote which decided upon XML, and then it was decided that we would regroup the format, the description of the data classes, and the XML implementation to facilitate implementation. And around 2007, the working group was closed, and all the documentation was published as experimental RFCs. Almost 20 years after that, the question is, what feedback can we have from that? First of all, we've seen a widespread deployment of security information and event management systems in SOCs, and we have now SOAR events, things like that. So we have seen a massive update of the technology, which was not completely obvious when we designed the format initially. We also saw that most SIEMs are implementing nowadays a structured format for importing the information that comes from various sources. So this confirmed the need, which was kind of a difference from the original initial purpose of comparing intrusion detection systems. There were a bunch of technical updates that occurred over the years. AI became prevalent, and that created a requirement with a list of a need for clear semantics, and we had decided originally to use closed lists of values to do that. We were keen on XML, but clearly today the format of the transport of choice would be JSON. We didn't see so many cyber physical systems by the time, but clearly they have become a major source of data. And we have also seen the emergence of cyber threat intelligence with its structuration. Some efforts were already there, but it has gained a lot of momentum and it's now implemented in SOCs largely. And in the end, the lesson that we can draw is that a detection-oriented format that should support operators in deciding whether there is an incident is different from a log format, which IDMEF fundamentally really is. And there have been multiple initiatives which, similarly as IDMEF, had difficulties to uptake. We had the common event format from MITRE. Syslog has seen several instances. It's widely deployed, but it hasn't standardized well. And so we came up with these needs that the IDMEFv1, RFC 4765, needs to be updated in order to support the development of SIEMs and cybersecurity in general. So a few words about the SAFE4SOC project. So SAFE4SOC is a digital project from the ECCC. It was in 2022 Cyber Call. And the objective is to propose solutions for SOCs to exchange information, and particularly in a cross-border manner. As a EU project, it should encompass multiple member states. It's a 3-year project, started in January 2024. We're the coordinator. It has now 11 partners, a budget of 7 million euros, with a funding rate of 50%, and you have the grant agreement, and many of our documents are publicly accessible, either from the Commission or from our various repositories. So where do we start? It's clear that security operations have become more distributed, more heterogeneous, and more cross-domain, in the sense that there are many application domains that need to exchange information in a structured manner to improve the situation. Local security operating centers see signals, but in order to exchange them, apart from calling one another, they need some structure in order to facilitate exchange, because these signals are locked into proprietary formats. And clearly, this is an effort that has been ongoing for quite some time, either in the French or in the EU circles. So today's webinar purpose is to show you how we implement that in practice, explain the format, demonstrate its usefulness over a few, particularly in the case of situational awareness, and show you pilots and connect our pilots to end users in order to show you the value of the topic. And in the remainder of the webinar, we will be talking about these core questions. How can local SOC alerts become shared in order to improve operational awareness? Why are we here? We see heterogeneous SOC tools. Actually, in the project, there are several implemented in the pilots. We have local SOCs who are doing fine, but they remain in their closed environments. And we see also a growing convergence between the cyber world, but also the physical, and also incidents that come from sources that are not necessarily cyber or malicious cyber, but they also come from the physical world or from accidents or failures. And so without a common alert exchange layer, the cooperation becomes more difficult. People talk to one another, but they don't have a structured way of doing so, and they do that in ad hoc ways, which lowers it increases the difficulty, and it lowers the usefulness of the exchange. And so our objective is to address this topic by combining first a standard format, so people have the same kind of information and they have a clear semantic about what they want to exchange. We have gateways, and these gateways have the property of protecting information so that we have built-in compliance with, for example, via GPD. We control the sharing through that. We have a central monitoring, and we also demonstrate how artificial intelligence tools, which are prevalent in SOCs today, can benefit from the use of clear semantics in the data that they ingest. And so each of these sessions will answer some of these questions. The first section will talk about the common format to show you how IDMEFv2 structures alert and incident information. We will then demonstrate the workflow and the gateways to show you how an alert can progress from the local SOCs to outside. A central situational awareness platform that we call Concerto. The enrichment of alerts and multi-source analysis by artificial intelligence tools, and then demonstrations and pilots. The goal is not just to present components in an heterogeneous way. We want to show you how operationally this works as a global architecture that can be shared, that is rooted in standards, and that can be adopted widely in order to facilitate information exchange. So in the operational SIEM, IDMEF and SAFE4SOC are located both in the alert exchange format and in the central SIEM. These are two components so one is a paper documentation, but the other is an actual software that we develop. We import data from local SOCs, so we adapt local SOCs so that they can handle IDMEFv2 data. We connect those through gateways to transform them to IDMEFv2. IDMEFv2 provides information to the central SIEM through the information sharing gateway, which in turn can provide analysis and validation of the information using AI tools. Local information, local semantics is preserved. We control how it's shared, but the central view enables even the local SOCs to better fight cyber threats by providing them with feedback on whether others, for example, have seen the same kind of patterns, or if responses provided by others have been implemented and have had some efficiency. And so we believe that by improving information sharing and demonstrating how it works in practice, we shall improve the way SIEMs and SOCs operate in the future and are more efficient, and probably, and all of this is supported by tools which enable automation, which is quite important in the domain given the quantity of alerts that we have to deal with. So there are a number of takeaways that we would like you to keep. Interoperability is important because then it means that you remain you keep the choice of the technology you want to use, and clearly the technology that you understand is important for you. But we improve interoperability between technologies that are currently independent. We understand how sharing can be controlled. We share also the life cycle of alerts, how we can receive new incidents, handle them, and close them in a structured way. Globally provide more information. We call that situational awareness, but it's a new kind of CTI, really. We include the cyber-physical world in the context, including availability issues, including physical components, including hazards that we can treat all of them together. And we hope that in the future, adopting this solution can help several kind of organizations adopt this technology and gain efficiency, operational efficiency.